Hello student, welcome back to maths class, and today we'll do playing with construction. Our learning objective in this chapters are artwork, squares and rectangle, constructing squares and rectangle, and exploration in rectangle, exploring diagonals of the rectangle and squares, point equidistance from two given points. So all these things we are going to learn in this chapter. We'll start with introduction. A ruler is a fundamental tool in geometrical construction, mainly used to drawing straight lines and measuring distance accurately. While rulers are limited to measuring and drawing straight line, there are essential companion to tools like compasses and protractor in the creating accurate and the well proportional geometrical construction. So you can see in your geometry box, you can see the ruler, you can see the protractor, you can see the compass. So all these things are used in geometry to construct shapes and different things. A compass is a tool used in geometry for constructing various shapes and measurements, especially involving circles and arcs. Using compasses require precision, as even slight change in the radius can affect accuracy. So precision should be there, especially in the complex constructions. In this chapter, we will play with the constructions using the scale and pair of compasses. Artwork. Start with the ruler. A ruler is a measuring tool used to draw straight line and measure distances. So you can see the ruler in your geometry box that is used to draw straight line and measure the distance. It typically consists of the flat straight edge marked with the unit of length such as centimeter and inches, and is often made from the material like plastic, wood or metal. Rulers are commonly used in geometry, drafting constructions and various crafts or tasks require precise measurement. So there we use ruler to draw straight line and measure the distance. You can see the marking centimeter and inches. The other side in inches. The ruler is marked with a scale to show the unit of measurement, allow for accurate measurement. The most common unit, the ruler, are centimeter and millimeter on metric ruler, and inches and fraction in inches on imperial ruler. So you can see on the ruler the marking is here in centimeter, the small division shows millimeter, and this side it shows inches. Next is uses of ruler. So now we'll see what are the uses of ruler. Drawing straight line. So whenever we want to draw a straight line, we use a ruler. It provides the guide for the drawing straight lines, essential in technique drawing geometry. Next is measuring length. Ruler help to determine or verify the length of the object, distance and dimension. So we use ruler to measure the length. Next is construction and design. Assist in the precision for layout and the structural design. Next is art and craft. So ruler is used in art project, scrapbook and any activity require exact dimension. There we use ruler. Next is protractor. Another instrument that we find in a geometry box, that is protractor. Protractor is a geometrical tool used to measure or draw angles. It is typically made of transparent plastic or metal, allowing user to see the surface underneath while aligning it with the lines and points. Protractors are commonly semicircular in shape, although some are circular, and they are marked with a degree measurement from 0 to 180 degree for semicircular protractor, or from 0 to 360 degree for circular protractor. So you can see this kind of instrument in your geometry box, that is a protractor, that is mainly used to construct or draw angles. Clear? Protractor have the scale marked in degree, often from 0 to 180 degree and 0 to 360 degree with the increment of 1 degree, 5 degree, 10 degree for accuracy. The outer edge of the protractor usually has these degree marking in the both clockwise and counterclockwise directions. The center point or the origin is located at the middle of the straight edge of the midpoint of the circle diameter. The point is placed on the vertex of the angle being measured or drawn. The baseline is the straight edge at the bottom of the protractor. which is aligned with one arm of the angles or with the baseline to measure or construct an angle. So, you can see this is the projector, this is the midpoint center point, and this is the baseline. You can see this is the baseline, and you can see marking from 0 to 180 degree clockwise and 0 to 180 degree counterclockwise or anti-clockwise. Next is compass. Another instrument that we can find in a geometry box is a compass. A compass is a drawing tool used to geometry to draw circles. So, mainly we use compass to draw circles, arcs and mark distances. It consists two arms connected a pivot point. One arm has the pointed and the anchors of the compass on the paper, while the other hold the pencil or pen. For the drawing, compasses are used in mathematics, drafting and technical fields when accurate geometrical constructions are needed. So, you can see this kind of instrument in your geometry box, that is a compass. This is the hand. It has two ends, one is pointed end, that metal tip, and another, and we fit the pencil to draw the circle. Next is circles. A circle is a simple closed shape in the geometry where all points are an equal distance from the fixed center point. This fixed distance is known as the radius of the circle. All are the fundamental shape studied in the mathematics and have unique property that distinguish them from the other shape. So, this is a circle, this is a center of the circle, and it is a radius. Every point on the circle that should be equal distance from the center. Next is method of drawing circles with the compass. So, now we learn how can we draw the circle using compass. Steps: set the radius. So, first we have to decide the radius of the circle we want to draw. Use a ruler to adjust the compass by placing the point of the compasses of 0, extending the pencil and the desired radius length on the ruler. Lock the compass at this radius if possible, so it doesn't shift while drawing. So, first whatever radius we want to take, we'll measure that distance on ruler with the help of compass, and then we will not move the compass. The end should not move, the distance should not change, that we have to keep in mind. Next is position of compass. Place the pointed end of the compass on the spot where you want to center of the circle. Be ensured that the compass point is stable and it will act as the pivot of the circle. So, first we will, if we want to draw a circle, what we will do? We will fix the needle tip at one point, that would be the circle center. Clear? Now, draw the circle. Holding the compass point steady, rotate the pencil and around the center point, keeping the compass at the same angle to maintain the radius. So, without moving or adjusting the distance, whatever radius we have taken, we will fix the metal tip on the paper and then we will rotate the other arm, the pencil one, and draw the circle. Clear? Next is move the compasses slowly and steadily and complete the smooth circle. Avoid shifting the pivot point to keep the circle accurate. Clear? So, that we have to make sure that it will not move or the distance will not change. Clear? Next is finish and adjust, that is optional. Once you made the complete rotation, check if the circle is smooth, properly closed. If needed, go over any faint areas and adjust the line for consistency. Next is solve example. So, here we will take some examples. Example 1. Draw a figure in the given form to depict a person. So, here step 1, start with the base of the diagram. We will take a line AB. So, here we have drawn a straight line AB, that is of length of 4 centimeter. Now, step 2, at the A and B, draw the perpendicular lines using the protractor. So, using the protractor, we will draw perpendicular lines, 90 degree angle. Next step is step 3. Now, use the ruler, mark the points C and D such that AC 4 centimeter and BD 4 centimeter. So, mark the points so that AC, that should be 4 centimeter, and BD, that should be 4 centimeter, and join it by line CD. Now step 4. Now using the ruler, take a point M on CD such that CM 2 centimeter. So we'll take a point M on CD. This is the line CD. We'll take a point that should be in middle of that line. That will divide the given line into 2 equal halves. So that CM, that should be 2 centimeter, it will be also 2 centimeter. So M is the midpoint. M is what? The midpoint of CD. Using the protractor, draw the perpendicular CD at M. Take the point P on this perpendicular such that PM 2 centimeter distance PM can also be slight less than the or greater than 2 centimeter. Clear? So like this, we will draw a perpendicular here. Now step 5. Join PD. So we will join P point to D point, that is PD. Clear? Now an arc from the D to C. An arc from D to C. This arc of the radius equal to PD. This radius, that is equals to PD. Clear? Draw a circle of the radius 1.5 centimeter. Extend PM to touch the arc. Now we'll draw the circle of 1.5 centimeter radius. Now erase all the extra line. So what you will get? You will get this figure. Clear? So this will represent the required depiction of the given person A. Clear? Next example. Draw a figure in the given form and depict the wavy wave, where the wave are half circled. So we'll start with making a center line AB. That length is 8 centimeter. Clear? Now step 2. Since 8 divided by 2, because we have to find the midpoint, just half of it, so we'll divide by 2, 4. Using the ruler, take a point C. So we'll take a point C on such that it will divide the given line into 2 equal parts. So it will divide AC and CB. It will divide AB into 2 parts, AC and CB. Clear? Now what we have to do? Now we will divide this AC into 2 equal parts. So we'll take D point here and E point here. So here AD is 2 centimeter, DC 2 centimeter, C is 2 centimeter, and EB is 2 centimeter. Now step 3. With the center at D. Now we are taking center at D. Draw the semicircular like this. We'll take D as a center and draw the semicircular line in AB of the radius 2 centimeter. Radius is 2 centimeter. With the center E, we'll take E as a center and draw the semicircular below. That's radius is also 2 centimeter. Clear? Now what we will do? We will draw vertical line like given here in the semicircle above and below line AB. So that will represent the required depiction of the give wavy wave. Clear? Next is learning point 8.1. So you have to practice all the questions given here. Squares and rectangle. First we'll take square. A square is a 4-sided polygon or quadrilateral with the following characteristic. All 4 sides of square are equal, that we know that all 4 sides in squares are equal. Each of the 4 interior angle that is of right angle means 90 degree. Opposite sides of the squares are parallel to each other. The square has 4 lines of symmetry and rotational symmetry of order 4. Look at the same after the 90 degree rotation. It will look like same, so it have the rotational symmetry of order 4. If we talk about the diagonals of the squares are equal in the length, bisect each other at the right angle. So diagonals are equal in length and bisect each other at right angle means 90 degree, and divide the square into 2 congruent right angle triangle. In the figure given above, ABCD is a square. In the square ABCD, so this is a square ABCD here. AB, BC, CD and AC. all are equal. Next is rectangle. A rectangle is a four-sided polygon or quadrilateral with the following characteristic. Opposite sides are equal in rectangle. Each of the four interior angles, that is of right angle, opposite sides of rectangle are parallel to each other. The rectangle has two lines of symmetry along the length and width. The rotational symmetry is order 2. Look at the same after 180-degree rotation. Because in rectangle opposite sides are equal, so it will show the rotational symmetry of order 2. The diagonals of the rectangles are equal in length and bisect each other at right angle. So, the diagonals of the rectangles are equal in length and they will bisect each other and divide the rectangle into two congruent right angle triangle. Clear? So, here this is a rectangle ABCD. In this rectangle, you can see the side CD and AB, they are equal, and AC and BD, they are equal, opposite sides are equal. Clear? Now, the angle A, B, C and D, each are of 90 degree. All the angles A, B, C and D, they are of 90 degree. Clear? The rectangle ABCD can also be written BCDA, CDAB, DABC, ABCD, ADCB, DCBA or BADC. So, we can name the rectangle in any ways. In writing the rectangle, the concurrent must be occur in order to travel around the rectangle starting from any corner. So, we can start with any corner, like if I start with here BDCA, I can't write BCDA, it should be in order. Start from here DCAB, like this. Clear? Note carefully, the above rectangle ABCD cannot be written ACBD or CDBA, etc. Since opposite sides of the square are always equal, so every square is a rectangle. Next is rotated rectangle and square. When the rectangle and square are rotated, so when we rotate square and rectangle, what happens? It retains its geometrical properties through its orientation change. Draw the rectangle ABCD on the paper, cut the rectangle along the side, let it be rotate as shown the figure. So, this is a rectangle. Now, if we rotate it, it will look something like this. The rotate figure 2 of the rectangle 1 is also a rectangle. That is also a rectangle because its opposite sides are equal and each angle is of 90 degree. Thus, the rotate rectangle is also a rectangle. Similarly, we can verify to rotate the square is also square. Here, look at the rotate and rectangle and square. First, rotated rectangle. Even after rotation, the rectangle still has the opposite sides equal, so it will not change. The opposite sides will be equal and parallel with all the angles remaining 90 degree. When viewed at an angle, the rotated rectangle might appear as a parallelogram due to the perspective, but it maintains its rectangle properties. A rectangle has the rotational symmetry of 180 degree, so it rotates halfway around. It will look at the same as it did initially. So, in rectangle we have order 2 of rotation symmetry. Rotated rectangles are often used to design the architecture and create dynamic visual effect as they direct attention along diagonal lines. Clear? Next is rotated square. So, now if we rotate a square, it changes its orientation, but it remains the square with the equal sides and 4 right angle. That will not change. A square rotated by the 45 degrees is often called the diamond shape. Through it still retain all the property of square. The square has the rotation symmetry of 90 degree, so it will look identical every 90 degree rotation. It has 4 lines of symmetry. Rotated squares are commonly used in pattern styling and art to create symmetry and visual interest. Rotated square and rectangles are widely utilized in graphics, design and styling to create patterns and dynamics. visual effect while maintaining the mathematical properties of the shape. So, if we rotate square or rectangle, its properties are not going to change, only orientation will change. Next, we will take some example. Example 1. Draw the configuration of one rectangle and 4 square on the square dot paper as shown in the figure. So, solution: first we will take a square dot paper and mark a dot on it at A. A start and move 10 dots to the right and mark 10 dot at B. So, after 10 dot we will mark the point B. Start from the B and move 6 dot, because rectangle, so its opposite sides will be equal. So, like this is 10, and then like this it is 6, again 10 and 6. Clear? Now step 3. Take point E and F, G and H on the dot paper as shown in the figure. Take point I, J, K, L at the distance of 4 dots. E, F, G, H represent the point I, F, J, G, K and L, H. On L, H and G, K, construct square above the rectangle. On I, E and F, J, construct square below the rectangle. Figure given below is the required configuration of rectangle with 4 square on the square dot paper. So, like this we can draw one rectangle and 4 square on the square dot paper. We will take example 2. Identify if there is a square in this collection, use measurement if needed. So, we have to find out is there any square. So, in the figure 1, AB, BC are not equal. In this figure, AB and BC, length and breadths are not equal. So, it is not a square. In figure 2, you can see BAD is not equal to 90 degree, because in a square all the angles are 90 degree, that means this is not a square. In figure D, this one. So, in figure 3, if we count the dot, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So, that means it is a square because all sides are equal. In figure 4, in this figure counting dots between the sides, we will find that AB, BC, CD, DA are all equal. Also, using the projector we find that each angle of ABCD is 90 degree. Here we have rotated but sides are equal, so it is a square. So, ABCD is a square. Now, we will take another example. Draw at least 3 rotated square and rectangle on the dot grid. Draw in such that their corners are on the dots. Verify the square and rectangles that you have drawn satisfy their respective properties. So, we have to draw 2 rotated square and 2 rotated rectangle on the dot grid paper such a way that their corners are squared and rectangles are on dots. Clear? So, for that we will draw 2 rotated square like 2 and 3, 2 and 3, clear, and 2 rotated rectangles like 1 and 4, clear. These squares and rectangle drawn keeping in view that the number of dots between the sides is always position of side. So, there should be always in corner. 1, 2, 3, how many dots are there? 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. Clear? So, by counting the dots, you can draw the square, you can draw the rectangle. Using the protractor, we find that all angles on the figure 4th are 90 degree. Using the ruler, we find that the opposite sides of figure 1 and 4th are equal and all sides in figure 2 and 3rd are equal. By definition, figure 1 and 4 are rectangles and 2 and 3 are square. Next is construction, square and rectangle. So, now we learn how to construct squares and rectangle. Constructing squares and rectangle require precise measurement to ensure the equal sides or equal opposite sides and right angle. Now see how can we construct a square. So the tools needed are ruler, compass, square and pencil. Step 1. Draw a straight line of the desired side length, say AB. So first we will draw a line of desired length AB using the compass. Place the point A, set of the length AB, swing at the arc that the point A that the intersect above AB. Repeat from the point B, E to intersect the arc from the A at the point C above AB. Now draw the lines AC and BC. Clear? Next step, repeat the same process. So we have to repeat the same process to draw the line perpendicular to AB from C that intersect another arc from B to find the point D. Step 6. Connect AD and CD to complete the square ABCD. So first what we'll do, draw a line segment. Suppose these are AB. Now using the compass, we'll place at point A and draw an arc, and B draw an arc. Now I'll draw the perpendicular here and join these points. That will be the square ABCD. Clear? So like this we'll draw. Next is constructing a rectangle. So now we will learn how to construct a rectangle. Tools are needed: ruler, set square and pencil. Step 1. Draw a straight line of the desired length, say EF. Next step, using the set square or the projector, draw the perpendicular line from the point E of the desired width, marking it as a G. Now step 3. Repeat the point F to draw a perpendicular line of the same width, marking the point H. Now connect point G and H and complete the rectangle EFGH. Same way, but we have to keep one thing in mind, that in square all four sides are equal and in rectangle opposite sides are equal. So first we will draw a line segment of desired length, suppose that is EF. Now using the square or a projector, draw a perpendicular line from the point E of desired width and marking it G. Now repeat the process with F and draw the perpendicular and mark it point H. Now we will join the point G and H, and that will be our required rectangle EFGH. Next, we will take some example. Example 1. So now you will better understand this with example how to draw a rectangle and square. So here we have to draw a rectangle with the side length 4 cm and 6 cm. After drawing, check if it is satisfied the rectangle properties. So we have to draw a rectangle. We shall draw a rectangle to form shown in the figure 15. So first what we will do, we will draw a line segment AB that is of 6 cm. Clear? Step 2. Using the protractor, we will draw two perpendicular, one at A, another at B. Now step 3. Using the ruler, mark the point P perpendicular line such that AP is 4 cm. So from 4 cm we will draw a point. Clear? So this point, and from here B will draw a point after 4 cm using the ruler. Clear? So we have to, these points are A, B. Now PQ. Clear? So these are the point PQ. Now we will join them, and that is our required rectangle. Clear? Using the ruler, now we have to verify. So using the ruler we will verify PQ, that should be equal to AB, and QB, that should be equal to PA. Clear? And each angle should be of 90 degree. That means it is a rectangle. Clear? Next example. Draw a rectangle of the side 2 cm and 10 cm. So sides are given 2 and 10 cm. After drawing, check if it satisfies both the rectangle properties. So what we have to do? First, using the ruler, we'll draw a line segment AB that is equals to 10 centimeter. Now, using the protractor, we'll draw two perpendicular lines on A and B respectively. Clear? Now, using the ruler, mark the point P on the perpendicular at such that AP should be 2 centimeter. Now, from B, we'll draw a point, we'll mark a point of 2 centimeter and join them. Join P and Q using the ruler and erase the lines above the PQ. Clear? So, this is our rectangle ABQP. Now, we have to verify whether it's as a rectangle or not. So, how will we verify? Using the ruler, verify that the PQ is 10 centimeter. So, from ruler, taking ruler, we'll measure the distance that should be equal to 10 centimeter. That means PQ should also be 10 centimeter and this BQ and PA that should be 2 centimeter. Clear? Now, we'll check that all the angles A, B, Q and P that should be of 90 degree. Clear? So, that means this is a rectangle. Next, is it possible to construct a four-sided figure in which all the angles are equal to 90 degree but opposite sides are not equal? So, let's try. Using the protractor, draw a perpendicular. First, we'll draw a line segment AB. Now, we'll draw two perpendicular like this, which we have drawn earlier also. Next step, now using the ruler, mark point P on the perpendicular at A such that AP 4 centimeter. Using the ruler, mark point Q on the perpendicular B such that BQ is 2 centimeter. So, we'll mark the point here, AP should be 4 centimeter and BQ that is 2 centimeter. Clear? Which is not equal to AP. Now, in the figure 3, opposite sides AP and BQ, they are not equal. Clear? Now, we will join them together. Now, step 5. Now, we will take the protractor and find neither P and Q is 90 degree. So, we conclude that it is not possible to construct a four-sided figure in which all angles are 90 degree and opposite sides are not equal. So, that is not possible. Next is an exploration in rectangle. Draw a rectangle ABCD on a sheet of paper. Pick AB 7 centimeter and BC 4 centimeter. Now, we have to define the point X and Y. Imagine X is the point that can move along the side AD including the endpoints A and D. Imagine Y is the point that can move along the side BC including the endpoint B and C. Next is to measure the distance. Like here you can see these are the point X and Y which can move. Clear? Next is measuring distance. Select position of X and Y on the sides AD and BC respectively. Use the ruler to measure the straight line distance between X to Y, the length of the segment X and Y. So, these are the different situations here. A, B, C, D. Here what we have done, there is a point X here and Y here. It is from 1 centimeter distance from here and this is 5 millimeter. Here this distance is 1 centimeter and this is 2 centimeter. In this case, B that is equals to Y and D equals to X. And in this case, A equals to X and B equals to Y. So, it will look something like this. Clear? Next, analyze the minimum distance. Now, place X and Y at different positions along the sides of the rectangle, which we have seen here. Observe the measure to find the position where the distance between X and Y is the smallest. Compare these minimum distance to the length of AB, that is 7 centimeter here. Clear? Next is explore the farthest distance. So, adjust the position X and Y to find the minimum possible distance between the 2 points. Measure and record your finding. So, what should be the minimum distance between the position X and Y? Next is experiment with the multiple rectangle. To better understand this relationship, draw multiple copies of rectangle and try the various position of x and y and note that what is the smallest distance and how their distance change. Next is reflect. What pattern do you notice about the minimum and maximum distance? Are they a specific point on x and y that consistently give the same result? So, you have to try with more and more rectangle and try to find the maximum and minimum distance between these 2 points and observe the pattern. Next is construct a square within a rectangle. So, we have to construct a square within a rectangle. Construct a rectangle of side 8 cm or 4 cm. How will you construct the square inside shown in the figure such that the center of the square is the same as the center of rectangle? So, these are the steps for construction. Construct the rectangle. First, what we'll do, we'll construct the rectangle. Draw a rectangle ABCD with the dimension 8 cm by 4 cm. Now, find the center of the rectangle. Draw the diagonal. For that, we will draw the diagonal AC and BD of the rectangle. Mark the point of intersection like rectangle. So, this is the center point. Clear? So, draw the diagonals AC and BD of the rectangle. Mark the intersection point O, which is the center of the rectangle. So, this would be the center of the rectangle. Next is determine the side of the length of square. The square side length will be less than both 8 cm and 4 cm to ensure it fit inside the rectangle. So, we have to construct the square inside the rectangle. So, its length and breadth should be less than 8 cm, 4 cm. Let's denote the side's length of the square as A. Choose the appropriate value for such that the square fits perfectly inside the rectangle. Now, position of square. Now, we are taking O as the center of the square. Draw the horizontal line segment of length 2 on the either side of O. Mark these points as P and Q. Similarly, draw the vertical line segments of the length 2 above and below the O. Mark these end points as R and S. Next, complete square. Join the point P, Q, R and S to form the square PQRS. Now, we have to verify the center. We have to check whether the diagonals of the square also intersect at O, confirming that the square center align with the rectangle center. Next is construct falling squares. So, we have to construct these kind of falling squares. Make sure that the squares are aligned the way that they are shown. So, they should be aligned like this, that's shown in the figure. Now, we have to try this. So, we'll make a square and the square of side 7 cm, this is square of 5 cm and this is square of 3 cm. So, using the ruler and protractor, we can draw these falling squares. Clear? Next, construct shading. Construct this. Choose the measurement of your choice that the larger 4 side figure squares are so that the smaller one. So, we have to make this kind of shading square. So, first we will make the squares. You can see the small square, draw the diagonals and shade one part. So, now we will see how can we construct it. Steps to construct the shaded squares. For that, draw a large square. First, we will make a large square like this. This is a large square. Clear? Here we have taken side as 10 cm. Using the roller, draw the square ABC such that all sides equal an angle 90 degree. Now, we have to locate the center of the larger square. Now, we have to locate the center. For that, we have to draw the diagonals. Draw the diagonals AC and BD, mark the intersection point O, which is the center of the largest square. Now, we have to divide the square into 4 smaller squares. So, we will draw the horizontal line and divide the square into 2 equal halves. Draw the vertical lines through O that divide the square into 4 smaller equal square. Next, shaded specific squares. Now we have to decide which of the smaller square to be shaded, whether it's from top left, bottom right square, which one, that we have to decide. Use a pencil to lightly shade these squares evenly. Next is, that is optional, adjust and add more details. You can further divide the smaller square into even smaller shapes and shade specific section based on the desired pattern. So whatever pattern you want, accordingly you have to decide, so which part should be shaded, how to construct the squares. Next is, construct square with a hole. So for that, observe that the circle hole is the same as the center of the square. Now steps, first we have to draw the large square, decide the side length of the largest square. Here we have taken it as a 10 centimeter. Now using the ruler, draw the square ABCD with all sides equal and all the angles should be 90 degree. Now we have to locate the center of the largest square. For that we will draw the diagonals. The point of intersection would be their center. Now draw the smaller square or inner square. Decide the side length of the smaller square. Suppose we have taken here 5 centimeter. Now place the smaller square such that its center coincide with O, means the center should be same. To do this, measure half of the side length of the smaller square along the horizontal and vertical axis from O. Clear? Now we will mark these points to form the vertices of smaller square. Now connect the vertices to complete the small square. Now we have to create the hole. For that, erase the interior of the smaller square. Now we'll erase the interior of the smaller square and repeat the hole visually. Alternatively, shade the region outside the smaller square, the border area, to emphasize the hole so that we can see the hole. Next, that is totally optional, add the dimension. Whatever measurement you have taken, accordingly you add the dimension. Label the side and length of the larger square and the smaller square for the clarity. Next is, construct square with the more holes. For that, what we will do, choose the side of the length of larger square. First we will draw a large square. Use the ruler to draw the square ABCD with all the sides are equal and all the angles are 90 degree. Now plane the smaller square or holes. Decide the number of sides of the smaller square. 4 smaller square with 3 centimeter side here we have taken. Clear? Now arranging the smaller squares symmetrically or as per your design. So whatever design we want, accordingly we will plan. Next we have to locate the position of the smaller square. So for that we will divide the larger square into equal sections of the position of smaller square. For 4 smaller square, divide the larger square. So we have to divide the larger square into 4 equal quadrant, means 4 part, 4 small square. For more squares, create the grid within the larger square by dividing it horizontally and vertically. Mark the center of each smaller square within its assigned section. Now draw the smaller square. For that, for each smaller square, measure half of the side of the length of smaller square, that is 1.5 centimeter for 3 centimeter. Clear? Use this measurement to locate the corner of the smaller square and relative to its center. Cannot be the corner complete the square. Now we have to create the holes. For that, erase the interior of a small square and represent the hole. Alternatively, shade a border of the region outside the smaller square to emphasize the holes. Next, we can add the dimension. We will label the sides of the larger square and the smaller square for the clarity. Like we have done earlier, the process will be same and you will do the changes according to the design you want. Next is construct square with curves. So we have to construct a square with a curve. This is a square with 8 centimeter length. So first we'll draw the square. So first we'll draw the square. Decide the side of the square here 8 centimeter. Now we'll use the ruler to draw the square ABCD with the equal side and right angle. Now we have to divide the square. For that we will draw the diagonal AC and BD, mark their intersection at O at the center of square. Optionally draw horizontal and vertical line through the O to further divide the square into 4 equal parts, like here. This is the center, so we'll draw these lines. So this will divide to 4 squares. Clear? Next, add the curve inside the square. So for that, place the compass O, draw an arc extending the sides of the square, adjust the radius of the different effects alternatively. He placed the compasses at the corner A, B and C, D to draw the arc that intersect within the square, like here. We have to draw these arcs. Clear? Option 2, draw the circle. So we can also draw the circle. With O as a center, draw one or more concentric circles inside the square. Ensure the circles are smaller than the square to fit within its boundary. Option 3, use the divide section of the square to create symmetrical and intricate curve pattern. For example, curve connecting midpoints of the opposite sides spirals starting from the O and extending outward. Wavy lines cross the square sides. Next is finalize the design. Erase unnecessary construction line. After that, we'll erase all the unnecessary construction line to make the curve stand out. Optionally shade and color the areas between the curve for emphasis. Next is exploring diagonals of the rectangle and squares. Steps to construct a rectangle and its diagonal. So for that, we'll draw a rectangle first. So first we'll draw the rectangle. Draw a straight line of desired length AB. Now at a point A, use the set square or the protractor to draw the perpendicular lines that we have done earlier also. So first we'll make a line segment on A and B, that is line segment AB. Now at A and B, step 2, at the point A, use the set square or the protractor to draw the perpendicular lines from A. Mark the point D on such that the perpendicular line, that is the desired width of the rectangle. From point B, draw a line parallel to AD and mark a point C that align with the D horizontally. Now you have the rectangle ABCD. So we'll draw 2 perpendiculars and mark the points C and D and join them. This is our rectangle. Now we have to construct the diagonals. So for that, we will use the ruler to connect the point A and C. So diagonal join the opposite point. So we'll join these points. These are the diagonals. Clear? So this is the second diagonals of the rectangle. Like this, we'll draw the diagonals. Like here you can see in the above figure. In this figure, diagonal AC. This diagonal AC that divide the opposite angles A and C. So that will divide the angle A and C into 2 parts. Angle A 1 and 2, C 3 and 4. Clear? Now, angle 1 and 2 may or may not be equal. Next, steps to construct the square and its diagonal. For that, first we'll draw a square that we have learned earlier. For that, draw a straight line segment AB of desired side of length of square. Use the protractor and set square to construct the 90-degree angle point A and draw the line perpendicular or to AB. Using the compass, set it to the length of AB and mark the point D on this perpendicular line, the same distance from A. Now at point B, use the set square or protractor again to draw the another perpendicular line of the same length. Because in square all 4 sides are equal, so length should be same as AB to locate the point C opposite to D. Now connect the points C and D to complete the square ABCD. Now we have to construct the diagonals. So we'll take the ruler and draw the straight line from point A to C and D to B. Clear? These are our diagonals. These diagonals will divide angle A as 2 part 1 and 2, C 3 and 4. Clear? Here you can see in the above figure, the diagonals AC divide the opposite angle A and C into two smaller angles, 1, 2, 3 and 4. Angles 1 and 2 are equal and also angles 3 and 4 are equal. Clear? Two equal angles. Next, we'll take some more examples. Example 1. So we have to construct the rectangle in which one of the diagonals divide the opposite angle into 50 degree and 40 degree. So we have to construct a rectangle and draw a diagonal so that it will divide the opposite angle into two different angles, 50 and 40 degree. For that, what we'll do? First, we'll draw the line segment, that is AB 4 centimeter. Next, using the protractor, mark the dots C and D at angle 50 degree and 90 degree. 50 plus 40. So first, we'll draw the line segment using the protractor. What we'll do? We'll take A as a center and mark the dots at 50 degree. So we have to draw two angles because total is 90 degree. One is 50, another will be 40. So mark the point at 50 degree and total, that is 90 degrees. So another will be 40 degree. Now keeping the center point of the protractor at A. Now using the protractor. Now we will use the protractor and draw a perpendicular line to AB. AB at B. So we'll draw this perpendicular line that will intersect at point E. Clear? Now step 4. Using the protractor, draw a perpendicular line to BE. So we'll draw a perpendicular line BE at E from here and let it intersect the extended line AD at F. So it will intersect at the point F. Now we will erase all the extra line and this is our desired rectangle in which the diagonals are divided into two angles 40 degree and 50 degree. Another example. So we have to construct a rectangle, one of whose side is 4 centimeter and the diagonal is of length 8 centimeter. So for that, what we'll do? We'll draw a line segment of 4 centimeter, that is AB. Now using the protractor, we'll draw two perpendicular at A and B. Clear? Now we will take A as a center and radius equals to 8 centimeter. So A as a center and draw an arc. Now B as a center, draw an arc and join these points and these diagonals. So they are of 8 centimeter. Join the point of intersection by the arc like this and join the diagonals also. So that is our required rectangle with a diagonal of 8 centimeter and will erase all the extra lines. Point equidistance. Equidistance means from equal distance and from two given points. So step to construct the points equidistance from two given point. Identify the point, label the two given point as A and B. Now draw the line segment using the ruler. Draw the straight line segment connecting A and B. So we'll draw to find out 2 points A and B and using ruler join them like this. Clear? Now draw the line segment using the ruler. Draw the straight line segment connecting the point A and B. Now construct the perpendicular bisector. So we have to construct the perpendicular bisector. Place the compass at the point A and set the compass width more than half of the distance. So the compass length, that should be more than half of the length of AB. We'll keep the compass at A and draw an arc. And here also. Now we'll take B as a center, same radius, we'll draw another arc and join them. Clear? Now draw the arc above and below the line segment AB without changing the compass width. Place the compass point B and draw two arcs to intersect the previous above and below AB. So label the point where the arc intersect, that C and D. C and D. Use the ruler to join these points. the intersection points of the perpendicular bisector. So this point, that is the perpendicular bisector. So that will divide the given line into two equal parts. Clear? So the intersection point of the perpendicular bisector with the AB is the midpoint. That is this point. Suppose this is the point E. That is the midpoint of line segment AB. It will divide into two equal halves. So A will be equal to B. Clear? So you can verify the points of the perpendicular bisector equidistant from A and B, measuring the distance between each point. So you can measure the distance and verify it. Clear? Next, solve example. Example 1. Recreate the given figure. Note that all the lines forming the borders the house are of length 7 centimeter. So all lines should be 7 centimeter, which make the border of the house. So first we'll draw the line segment DE, like here, 7 centimeter. Now using the protractor, what we'll do? We'll make two perpendicular. Now take D as a center. We'll make a arc 7 centimeter here also, like this. Now third step, 7 minus 1, that is 6 centimeter, and 1 centimeter plus 2 centimeter, that is 3 centimeter. Using the ruler, take a point P and Q on the DE. So this distance is 1 centimeter, total 7 centimeter. So what we'll do? From D, we'll take the distance of 3 centimeter and mark a point P, and from E, we'll make a distance of 3 centimeter and mark the point in Q. Clear? Now D is such that DP 3 centimeter and QE 3 centimeter. Clear? Now we'll from P we'll make a line segment of 2 centimeter and Q 2 centimeter, like this. Clear? These are the point R and S. Now we'll join them together like this. Clear? Join R and S like this with the center B and C and radius 7 centimeter. Draw the arc to intersect. Now we'll take B and C as center and mark B and C as a center and make two arc of 7 centimeter and join them together. With the center A, the radius 7 centimeter, draw an arc from B and C, also erase the extra line. So we'll erase all the extra lines. Now in this figure, the required recreation will give the house with all the line forming the border, that is all 7 centimeter. Clear? Next example. Is there a four-sided figure in which all the sides are equal in the length but not the square? If such a figure exists, can you construct it? So we have to make a four-sided figure in which all sides are equal in length, but still it's not a square. So what we'll do? We'll draw a line 5 centimeter AB. Next step, using the protractor, take the points C and D such that the angles of the right of A on the right of B 60 degrees. So we'll make two angles, that is of 60 degree each. Clear? Third step, using the ruler, take the point P and AC such that AC 5 centimeter and Q on BD is such that BD 5 centimeter. Now we'll join them together. So all sides are of 5 centimeter but angles are of 60 degree. Clear? Now we'll join them together. Using ruler, we'll measure the distance PQ. So we'll measure the distance this PQ, that is equals to 5 centimeter. Clear? All sides are equal, but here you can see the angle A is of 60 degree, which is not equal to 90 degree. In rectangle, all the angles are of 90 degree. So this is a four-sided figure, but still it's not a square. Clear? We can find these, that there are four-sided figure which all the sides are equal, but still it's not a square. Next is learning point 8.2. So you have practiced all the questions given in the exercise. Next is summary. A ruler is a measuring tool used to draw the straight line to measure the distance. The protractor is the geometrical tool used to measure and draw angles. A compass is a drawing tool used to in geometry to draw circles, arc and make distances. A circle is a small, simple closed shape in geometry where all points are an equal distance from the fixed center point. Opposite sides of the squares are parallel to each other. Opposite sides of the rectangles are parallel to each other. Rotate square and the rectangle are widely utilized in graphics, design and tiling to create pattern and dynamics visual effect while maintaining the mathematical properties of shape. So, all these things we have discussed and learned in the chapter. This is the summary of chapter. Here we end the chapter. I hope you understand the chapter well. Now to practice it.